Okay, so today's lesson is going to be on the Fibonacci sequence. So this is 13.1. The Fibonacci sequence. Now you're going to start off with these two numbers, and then to find the next term, you add these two, then add these two, and those two. 3 and 5, 8, 5 and 8, 13. Let's list a few more. 55 and 34, 89, 144. So it is an infinite sequence. Now these first two are called the seeds. So your rule will be to obtain any Fibonacci number except the first two. Suppose I want 1, 2, 3, 4, 5, 6, 7, 8, 9. I want the 10th Fibonacci number. Well, if you know the 9th and the 8th, just add those two. So my rule each term is the sum of the preceding two terms. Now, as I said, if you want the 10th Fibonacci number, you add the 9th and the 8th. We are going to use an uppercase F for Fibonacci and a subscript. So this tells me I want the 3rd Fibonacci number. So you don't have to worry about F0. We don't have a 0. So this is more intuitive. So when you see F subscript 4, it means 1, 2, 3, the 4th Fibonacci number. As we said, if you want the 6th Fibonacci number, you add the 5th and the 4th. This is called a recursive rule. So, in general, here's your formula. To find the Fibonacci number, you take the 1 before n, that's n minus 1, and the 1 before that, add those two. For example, if you want the 10th Fibonacci number, then you need to know the 9th and the 8th. But let's suppose we do not have that. Then you got to go find these. So if we were to ask you to find the 25th Fibonacci number, you got to know the 24th and the 23rd, and so that's one disadvantage of the recursive rule. We have an explicit rule where you could find that directly, and that formula is called Binet's formula. Now I have that on a separate sheet on D2L, so you will need to print that. So let's take a look at it. So here's how we're going to use Binet's formula. So that part, to find the nth Fibonacci number, you're going to use that expression to the nth power, and you're going to divide by the square root of 5. So, for example, suppose we want to find the 10th Fibonacci number. Where you have n, you're going to put 10. Now you've got to be careful with parentheses here. So I've written it out for you. In the innermost parentheses, you have 1 plus the square root of 5. Now for some of you, your calculator, if you want the square root, as soon as you press that, your calculator may open parentheses. So you will have to put a 5 and close the parentheses. I do not have that. If your calculator needs parentheses opening, you're going to need to close it. And you still have that one. So try this, enter it carefully. Again, here you may have to write the square root of parentheses 5. If you do it correctly, you should get 55. Remember, you can go back to our list of Fibonacci numbers. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The 10th Fibonacci number is indeed 55. So I have some more examples here. If you want the 100th Fibonacci number, it's the same sequence of keystrokes, but now where you have n, you'll put a 100. Your calculator is going to approximate and write it in what we call scientific notation. Here is the actual number. You don't have to know the exact number. So I have another example. Now if you were to take these two numbers, take the 100th Fibonacci number and divide it by the one before it, the 99th, you're going to get 1.618. That thing that we call the golden ratio. You remember I mentioned it when we solved this equation. X squared is equal to x plus 1. One of the solutions was 1 plus square root of 5 all over 2. This is approximately 1.618. So if you divide any Fibonacci number by the one before it, providing you go far enough in the sequence, if I were to divide 55 by 34, you'll get approximately 1.618. You can pause the video and try that. Divide this by that. Divide this by that. It's not going to work so well for the smaller numbers. Now there are lots of applications of Fibonacci numbers, especially in nature. You can look at on your textbook on page 390, there are lots of pictures showing you the applications of Fibonacci numbers. Here's a picture of a chimney. This is in Finland. There's someone is maybe he's an engineer, a mathematician. They're so in love with the Fibonacci sequence, they have them lit up here. So I'm going to end this part of this video here.